Ron Wade with IDT, and today we're going to give you the lowdown on low power HCSL outputs in a nutshell. But first we have to understand what standard HCSL outputs are. These are used to clock PCI Express systems for the most part. And we have the standard HCSL, which is basically it's a constant current type of output. We have a current source providing 15 milliamps, and we steer the current between the true and the complement outputs. And you can see here the current is being steered to the complement output. So this 15 milliamps goes out this resistor in series with the output, and then it hits a pull-down resistor. So you've got the current flow going this way, and then this way. And so this 15 milliamps goes through here, which is typically 33 ohms, and then goes through this resistor, which is 49.9 ohms, and that result is you get your 750 millivolts on the line here. And then when the current is switched, you've got the 750 millivolts on the line, and when you disconnect the current source, the voltage, the charge on the line dissipates through this resistor to ground, and that's how this thing works. You're constantly steering a current back and forth. It's 15 milliamps per output for 100 ohm loads, and that's roughly from 3.3 volts. That is roughly 50 milliwatts per output, which is kind of high. The low power HCSL outputs are sometimes referred to as push-pull outputs because on the complement and the true line here, we actually have two transistors which are actually yanking the signal between ground and this thing called VDDO. In this case, VDDO is a constant voltage source, which would be set at approximately 750 millivolts for the high voltage. And then you have one common control line here, which when the complement is shorted to the VDDO rail, the true would be shorted to ground through the transistor and vice versa. That's why it's called push-pull. We're actually pushing and pulling the signal up and down. And because we're pulling the signal down to ground back through this path, there's no shunt resistor to ground on this termination. We only have series resistors. Power consumption-wise, this is in a 10-inch trace at 100 megahertz. It's about 5 milliamps. So you're already 1/3 the power of the other guy. And because this is a voltage source or a voltage regulator, you can actually power this from something less than 3.3 volts and save more power. So you save power, you have the ability to cut the termination resistors in half, and actually you can with this technology bring these series terminations inside for the most density on your board. That's low power HCSL in a nutshell. Thanks.